All right, rolling. Okay, so this is NetLogo. We're going to run the shelling model in NetLogo. And I'm going to walk you through what all these little parts mean one by one. This is called a slider. Okay, and we have number and percent similar wanted covered by sliders. And that just means, slider means that we can change the value of the number of agents in the simulation. I just made it about 1100. Or I can make it something like 2500. You can see the density increases. To the right here, the green and red are the agents on a grid. And, excuse me, sorry. What we're really going to focus on when we run the simulation is these two graphs down here. So this first graph just tells us on average the percent similar across all the agents in the simulation. And the second graph tells us the percent unhappy. Okay, we're going to track that throughout the simulation as we run through it. So what we want to first do is focus on running a simulation where the percent similar wanted is actually relatively low. We're going to start it at something near 30%. So that's already set up. We're going to set the number of agents to be 2,000. We set up the model, which initializes it. And you can see in the beginning, before anything happens, 50.4 are similar and 17.5 are unhappy. And what these graphs are going to allow us to do is track these two variables as the simulation goes on. So we set it up, and all we do is hit go, and we'll watch the model operate. It'll stop when everybody is happy or there's 0% unhappy. Let's see what happens. Okay, the model's done. Everybody's happy. So you can see what happened was the percent similar is 72.8. So people are really getting a lot of similarity, but they only wanted 30%. And you can see if you look at the agent checkerboard thing, you can see you're getting a high degree of clustering. There's a lot of red agents living together here. And you can see the same thing for green, for example. Up here, there's a large swath of green agents living together. What's kind of surprising about this is we only have a requirement at the individual level that people really just want to be around 30% similar, but they're actually getting 72% similar. So let's rerun the simulation. We're going to do the exact same thing. We're not going to change any parameters. We're just going to hit restart. Setup, hit go again. You can see it comes out to about the same thing, 73%. Let's do that again. Comes out again, 72%. If we ran this many times, you'd have the same result, which is a high degree of similarity, and you'd have a moderate degree of clustering on the checkerboard. Okay, so let's just move it up. The percent similar wanted, we're going to move it up to 40%. So this is increasing the amount of similarity people are interested in, but not too much. Set it up. Run it. Okay, now we're up to 79% similar. Let's do it again. It's looking kind of similar to the 30% similar wanted, but we're getting even a higher degree of similarity, 81%, when people really just want 40. Now what happens when we go up to, we'll just go up to a little bit above 50 to 52. And remember, this is each individual agent, they only want 52% of the people to be like themselves in their neighborhood for them to be happy. So that's actually not that bad, considering you only have two different types of people. They're really interested in 50-50. What do we get when we run the model? It's very high, a high degree of clustering, and people are getting something on average of 93% similar. And you can see that, these large clusters, like this in red, and you can see the same thing for green. Huge clustering. And what's surprising about this, again, just like in the case of 30%, 52% isn't really that high of a percent similar wanted, but you're getting a large degree of clustering. In other words, you're finding that people aren't really getting what they want, right? they want 52%, which is, in this case, it is actually a degree of heterogeneity. They like most people, almost most people like themselves, but they want some variety. But they're ending up living around people who are exactly like themselves. So that's one end of the spectrum. The other end is what would happen if we make the percent similar wanted really high, like something like 75%. What do we expect then? Let's just run it. So we have the simulation 4. So we set the slider to 75%. We hit setup, and we hit go. Notice it takes a while to actually stabilize. You're starting to see the clusterings form. Some big red and big green patches are starting to catch up. The reason it's taking a while is because the criterion's so high, nobody's happy until they get into situations where they really need a lot of people similar, so it takes a while for everybody to get settled. But once they do, you find that at 75% similar wanted, you get almost 100% similarity. And you have these huge clusters that take up half the checkerboard. Okay, that's just green, for example. So what happens if we go a little bit higher? And this isn't that surprising, right? The only thing that's surprising is it took so long. But that's actually not surprising either. The reason it took so long to come to an equilibrium is because the criterion was so high that it was hard to satisfy for each agent. Now let's just move it up to 80%. And we're going to make this go really fast. Okay. You can already get a sense, if you just look at the percent unhappy, as time goes by, this isn't really changing at all. It's just stabilizing. And if we ran this for a couple hours, nothing would really change. I've actually done the experiments, and other people have too. So what you're finding is the criterion is too high. When people want 80% similar, they can never really get it. So the model, people will just move forever and ever. You can see little clusters once in a while, but they never stabilize. Okay, so that's in a way surprising. When people really want, in this case, this comes from racial segregation. So when people are really racist, in this model, it says if you're too racist, you'll never stop moving. And it also says if you're really not racist, but you have a little bit of a preference of similarity wanted, you'll actually end up with much more racism and racial segregation than the people actually want. So there's one more interesting feature of this model, which is what we call a tipping point. So we already did 75%. Let's just do a 75 one more time. You can see we know it takes a little while, but we end up with really large clusters. We let that go. Okay, that's just about finished. That's what we expect. Now if we move it up to 76%, what do we find? Well, it operates just like it's 80. You can run this over and over, and 999 times out of 1,000, it'll never stabilize. And this is what we call a tipping point. A very small change in percent similar wanted changes the nature of how the system operates. It's called a bifurcation. And this is something else we see quite a bit in agent-based modeling of this sort. All right, we'll stop it. And in summary, you can see that the model has a difference between the microstructure, in this case, which is people's desires in percent similar wanted, and the macrostructure, which is what you get. What are the patterns across all the agents together? And they're not necessarily aligned. When people really don't have a strong preference, you still get a lot of segregation. And when people have too strong of a preference, you don't get any segregation. And you also have tipping points, which is a really strong change in system behavior based on a very small change in the percent similar wanted. And those three characteristics are really interesting in terms of racial segregation, but they're also characteristic of how a lot of different agent-based models work also.